Hi there, and welcome to this quick start tutorial for Motion Symphony for Unreal Engine 4. In this tutorial, we're going to do a quick guide on how to set up a character for motion matching. We'll look at pose matching and that in other tutorials, but the focus of this one is motion matching. We're going to go through quickly, skipping a lot of the details just to get you going. Please come back and look through this documentation to understand more and watch other tutorial videos. There is one prerequisite. I do highly recommend you read this, understanding motion matching, so you know what a trajectory is, you know what a pose is, and you have some basic understanding so that things make a little bit more sense. Now, without further ado, let's hop into Unreal Engine and get going. Now, this assumes that you have downloaded the example project and you have access to all the animations in that. They're all mocapped animations that are created for motion matching, so they're a really good way to get started. And also that you have installed the plugin. So let's get going. We're going to actually start by creating our character and just getting a lot of the setup out of the way. So I'm going to create a character and call it tutorial character. And we can double click on our character and I'll bring that down here. First things first, let's set up our mesh. So choose the skeletal mesh. I'm going to create the SK mannequin. I'll drag it down so that it's, in line with the capsule a little better, and rotate it so that it is 90 degrees. So I want 90 degrees or negative 90, because I need it to face the way that that blue arrow is facing to get it right. Now we do need to set the animation blueprint, and we don't have one yet. So let's just quickly create an animation blueprint, right click, animation, and we'll choose animation blueprint, and we'll use the UE4 mannequin skeleton, and we'll call this ABP tutorial. Okay, so that's just a placeholder for now, so we can slot it in and we'll edit that later. So ABP tutorial, we'll set that in the anim class here under animation so that our character is all set up. Let's add now a camera. So we're first going to need to add a component, spring arm, just a simple camera just for the sake of, so we can see what we're doing. I'm going to set that spring arm to 600 and I'll set the rotation to about 25 degrees, negative 25 rather, so that we're looking down on the character. And to that component I shall add a camera, and the camera is, hang on, let me just delete that. I should have probably added the camera first, so add the camera, and now I'll go to the spring arm and rotate that 25, negative 25, and we'll move it up first to about the chest. Alright, a few more things I want to do on the spring arm. I want to uncheck inherit pitch, yaw, and roll on the camera settings. That's just so that when our character turns, the camera doesn't turn with it. Okay, on our character itself, we want to go to a setting under pawn, and this use controller rotation yaw, uncheck that value. Because we're going to be using root motion, we don't want this to fight with the root motion. If you're not using root motion, then you can probably leave it on, but for the sake of this tutorial and getting some good animation without foot sliding, we're going to use root motion. If you want to do it yourself, you're going to have to deal with foot sliding in your own way with IK and such, but that is out of scope for this plugin. You need to use your own IK solutions for that. Okay, so our character is almost set up. Let's add one more component, and it's called the trajectory generator. Now this is the first Motion Symphony component, and we'll just leave it there. And the only thing I'm going to change here is the max speed. I was going to set that to 400 centimeters per second, and I'll leave the other settings. We will have to fill in this motion match config, but we haven't yet created it, so we'll come back to that a little bit later. I'll compile and save, and that is our character done for now. We will have to revisit it though. Let's get the basic setup for our animation graph done. First things first, we'll add an inertialization node. Now this is just a blending node. If you don't know what inertialization is, look it up in the UE4 documentation. It's just a different method of blending that is more efficient and actually gets better results. Now we're going to add a motion snapshot node. Now this is an actual Motion Symphony node, which basically does what it sounds like. It takes a snapshot of the animation pose, so that our motion matching nodes and our pose matching nodes can talk to it and ask it, hey, what's the current pose that I should be matching against? If you're going to have any animation IK in your graph, it should go here after the inertialization and pose snapshot node, but before the end. Let's add a state machine. And this is going to be an extremely simple state machine with just two states, idle and run. And I'm going to call this locomotion. Okay, we'll double click on that and we shall create a state called idle. And we'll create another state. We'll call this run locomotion. So this is going to contain all our running locomotion from starts, stops, turns, everything in just that one node. And I'll create a transition back. So in our idle, let's just add in a simple idle loop. Connect that up. There we go. We've got our idle playing. And in our run locomotion, we're going to add a motion matching node. And we'll plug that in. Now it's not set up, so it won't work. If I hit compile, we'll get an error. That's fine. We'll leave it for now and come back to it later. I'm just trying to get the framework set up. Now for these transitions to work, we're going to need a few variables. So I'm going to make one has move input. And then the second one is going to be is moving. So in our first transition, has move input, if it's true, we go straight to motion matching. And the reason why I split up idle and run moving, so like this is using motion matching and this is using just an idle loop, is because motion matching typically doesn't do idles very well. There's not a lot of motion in idles, and so it tends to like jitter a little bit, but we can easily just transition to an idle state and it's not really a problem. You could even use a pose matching node in here so that you have you know, you can land on each foot, and I'll show you that in a different tutorial, but for now we're just doing this for simplicity's sake. So we've got our transition to running locomotion, and we just need our transition back. And for this, I'm going to go has move input, and we'll just make a NAND node. So not and. Sorry. I don't think that's what we want. I think we actually want to have it like this. So is not, has not got move input and is not moving. And then we can AND. That NAND node seems to actually behave slightly differently, so I'm not going to use it here. So that is our transition rules. Basically, if we don't have move input and the character isn't moving, we still want to stay, then we do want to transition to idle. But if it's still moving and we don't have input, we want the motion matching node to still play like a stop animation before it stops moving. So last thing we need to do here before we move on, because we're running out of we need to do some extra work, make some assets for this to work, but we can go to our animation preview edit here, go to edit defaults, and we're going to turn root motion on for everything. So root motion from everything, therefore we can get root motion from our motion matching node. So let's come back to this a little bit later. We need to make a few assets now for motion matching. Motion matching in Motion Symphony is made to be very modular, so there's going to be a few assets that we can chop and change and move around. So let's do that right now. All of the assets are under animation. The first one we want to make is the motion match config, and I'm going to call this tutorial config. We get a little message just reminding us that we need to set up the skeleton for this. And we can do that here. We'll select the skeleton. It must be the same skeleton that our character is using or our animation blueprint. And we need to define the trajectory. Now, if you read through understanding motion matching like I said you probably should, then you'll understand what a trajectory is. And basically, here's the character, here's the past trajectory, and here's the future trajectory, and these are points along that. What we're defining in this trajectory config is we're defining these points. Now, these points need to be defined in ascending order. I'm going to add 5 points, just like our little diagram there. and they're going to be ascending from negative 0.66 seconds in the past, evenly spaced to 1 second in the future. And that's it. I pretty much always use this trajectory for motion matching. I haven't really found a reason to use something else, but you can add as few or as many as you like. I do recommend, you do have to have one in the future, otherwise it simply won't work. But yeah, 3 to 5 is pretty good. Now we go to our pose config, and this is basically saying which bones do we want to match. Now it can be very tempting, and a lot of people make this mistake of matching too many bones. They match the knees, the foot, the hands, the shoulders, the elbows, the head, everything. All you really need for general locomotion with motion matching is the left foot, the right foot, and the pelvis. You could replace the pelvis with the neck, but the results don't change too much from what I've noticed. It really depends on your game. If you have animation where the hand positioning is really important, like maybe sword combat or a boxing game or something, you might want to match the hands as well. It's up to you, but I wouldn't really match more than 5. It's getting overkill at that point. So we can close that and move on to our next module that we create. Now the tutorial, the config module is about what we're going to match. And now we're going to make a calibration module, which is basically how we match it. It's a set of weightings that operate in the motion matching algorithm. Tutorial calibration is what I want to call it. And it basically tells the system, what bones are more important, what trajectory is more important. We get another little reminder saying that we need to set things up in here, otherwise it's not going to work. And what that is we need to set the config module. So we'll just drag that in there. And you'll notice if you click this arrow down, after we drag this in, these arrays get populated. And you can see there's one for each bone. We had 3 bones and one for each trajectory point. And these are just a bunch of weightings. Now, fortunately, the defaults, which you can set here, are pretty good for motion matching in general. So I recommend not touching this and just leaving it as is for now. There's a lot of work that goes on under the hood with motion matching with Motion Symphony to normalize all the atoms in the config so that the calibration is quite simple. It's just a matter of what you think as the tech animator or whatever is more important. The only thing I will explain here is the quality versus responsiveness ratio. Now 0.5 means that quality and responsiveness are weighted evenly, which is a really good starting point. You should leave it at this if this is your first time doing it. But this helps us tweak our animation. What kind of game are we going for? Do we need lots of responsiveness or do we need more quality? And what I mean by quality is like the weight of moves, the weight shifting. When you stop, it takes a little bit of time to stop, because that's what realistic animation is like. People in the real world take time to stop, they take time to turn. So if you want more quality, or you move it to the left. If you want more responsiveness, you move it to the right. This could also be called the pose versus trajectory ratio, because trajectory weighting improves responsiveness while while pose weighting improves quality. Keep in mind that this is a trade-off, so going too far to any one side is going to negatively impact your game. Too much quality and your character will be pretty much uncontrollable. Too much responsiveness and the animation will be choppy, basically. So let's just leave it at 0.5 for now, and we can close that. One last module to create, and now this is the big one. This is what contains all of our motion matching data, is the motion data asset. So I'm going to call this tutorial motion data, and we can double click on it to open up its custom editor. Now, first things first, we need to set our motion matching config, tutorial config, and let's set the calibration while we're here. I'm going to uncheck optimize because we're not going to go over optimization in the quick start tutorial because we're just trying to get something up and running really quick. Now, your character should show up here, but if it doesn't, like I'm seeing here, just close the editor and reopen it, and there it should be. And that model is taken from your config, so whatever skeleton you put in there is whatever is going to show up in here. On this left panel here, we can see sequences, composites, and blend spaces. These are the 3 supported animation types for motion matching in Motion Symphony. However, because we're using mocap data that's made for motion matching, we're only going to need sequences. So let's click on Pick Animations and find the animations we want. Now, to keep things simple, I'm just going to use Run Animations. So I've typed in Run there, and I'm only going to use a subset of them because I just want a basic locomotion. We're not going too crazy here. So all the start stop takes, and I won't do turn stops, I won't do counter starts, I'll do plants, I'll do turn continue, I'll do run cycle, run snake, and run circle spiral. Now this walk, run, accel, decel, I'd use this if I was going to add walking, which I might later. And in the example project, you'll see that I have used it and I've got actual multiple states for that. So let's add all those in, and the list gets populated here. If we click on any one of them, we can actually preview our animation with a very familiar animation timeline. And we can see these animations, they're actually full mocap takes, they're not cut clips at all. And this green trajectory basically shows what the root motion is for the entire animation. But this data isn't pre-processed yet. We need to basically bake the data into what is called our pose library or our animation database. There's a whole bunch of settings that we can set for each animation, but again, this is probably a bit too far for a quick start tutorial, so we'll ignore this for now. There is one animation that I do need to do something to, otherwise there's going to be problems. Of course, all these animations start with T-poses, but that's not a problem because the start and end of the animations will be clipped off automatically. But this is a problem here because at some points in this animation we have teleports. If you watch this here, we have a quick teleport, and then he's off again. We don't want to include that. So there's a way we can get rid of that. We go to tags here and we click on track and we choose add tag track. I'm going to call this track do not use. It doesn't matter what you call it. It's purely cosmetic and for organizational purposes. And I'm going to get rid of all these teleports, but also, I don't need the starts and stops of this S curves. I've already got start and stop animations. So I'm going to create a tag do not, so I right click, add tag section, tag do not use, and we get this red tag here. I'll drag it out, covering the sections that I don't want to play. So basically any part that is tagged as do not use will never be played with the motion matching system. So I'm going to go up to there, and quickly I'm just going to fast forward this. I'll tag up the rest of this animation as well. Okay, I've gone along and tagged all that up. So these sections here, poses will be generated for them, but these poses will never be searched at runtime. So you're doing yourself a few favors. You're basically telling the system what animations you like. You're getting rid of parts that you don't want. You could use this for parts of animation that you just simply don't like you don't like a particular plant or a start, and you can just tag it out. But you're also doing yourself a favor because you're reducing the number of poses in your database, and that's going to improve efficiency. It's going to improve your optimization. So that's very good. Now, personally, what I tend to do is I have a neutral run cycle animation, and it's just a nice straight run that is very consistent and has several cycles within the animation. And I use this for my run cycle, and what I'll do is all these little cycles in between. So for example, these run start stop animations, I'm really only interested in the starts and the stops, and these in between parts from like here to here, I'll actually tag as do not use. I recommend having a look at the example project motion data and seeing how I've tagged out these sections in the middle because it's a bit redundant. I tag out some of the stops as well because there's so many stops, just to get rid of redundancy and kind of cull the database a little bit manually. But this should work fine for now because I've gotten rid of the problems, which is the teleports, which would cause major issues. I'm going to just hit pre-process now, and we see that a little loading bar came up very briefly. It was very quick. And the reason it's really quick is because optimization is turned off. But if I go to show here and now click on show pose data and reselect an animation, we should be able to see the actual pose data visualized. And we can see the trajectory, and we can also see the poses that were recorded or baked. So this is a good way to verify that your animation has baked properly. Keep in mind that if your animation does not have root motion in the source animation, then this won't work at all. You can't use it for motion matching. That does not mean you can't use that you have to use root motion at runtime. It just means the source animations have to have root motion. You'll notice that everywhere where I put these tags, you'll see if I put the playhead there, it shows do not use there. So you can confirm that that has worked as well. So that's all I'm going to go over for tags. There is one last thing that I will do though. I will actually go to the run cycle, and I might tag this one up with two different types of tags. So do not use, and I'm just going to tag out the beginning and the end because I'm not using this animation. I'm just going to tag up the beginning and the end because I'm not using this animation for starts and stops. I've already got animations for that. So I'll tag the beginning. So the start, okay, that's where I want the cycles to start. And I'll tag the part where he stops. So from about there. Now what I would usually do is I would make an actual loop. However, I just haven't done that here. I recommend you do, and when you pick the animation, just check this loop value here, and that will work nicely. But in this case, I haven't done that, and I'm going to add one more track, and this track I'm going to call cost multiplier, and we're going to add a tag section here called tag cost multiplier, this one, and it's a purple one, and just for everywhere that the do not use isn't, I'm going to add that tag there. And over on the left here, once I've selected this tag, I can go to the cost multiplier, and I'm going to put it at 0.85. So what does this do? Basically, it reduces the cost of all the poses in this section at runtime, meaning they're more likely to be chosen. And this is really important for run cycles because we want our run cycles to be really consistent. So if I pre-process that again, we can now see the cost multiplier here throughout this section is 0.85. And when we go to other animations, it's less likely to pick these other in-between parts because its cost multiplier is higher. So I think that's just about all we're going to do for the quick start tutorial. I generally go and do a lot more to continually improve the quality, but I think this is going to get a pretty good result anyway. So let's save this, and I'll close it. And we can continue setting up our other things, our motion matching node and such. So let's go to our motion matching node that currently has the error, and we'll set the motion data. So that's this value here, and we'll set it to our tutorial motion data. We'll set the user calibration to our tutorial calibration, and I'll hit compile, and that should work now. we do need a input for this desired trajectory here. So I'm going to add that here. So desired trajectory, and we can make it of type trajectory. Now we could drag it in here. Oh, I think I put a, there we go. You could drag it in here and connect it, but what I like to do, since 4.26, is bind it. So if we go to desired trajectory, we can just bind it there, and that is connected. We still need to set the trajectory. So let's go to our event graph and do a few things. So we get the pawn owner, and what we need to do is to get the trajectory generator component that we added to our character. But first we need to cast it to our tutorial character. Cast to tutorial character. And from there we get trajectory generator. And we want to check if it's valid. Now keep in mind, I'm just doing this for demonstration purposes. I would probably cache this. This is not best practice for blueprint coding or anything like that. Keep that in mind. I'm just doing things quickly so we can get something working. So if trajectory generator is valid, what we're going to do is we're going to extract the trajectory using the function get current trajectory. And we're going to set our desired trajectory variable there, and that's just about done. Now the only other thing I'll do here is I will get something else from the trajectory generator, and that is the hasMove input variable, which we can set immediately afterwards. So I'll just call this function hasMove input on the trajectory generator. And we can set that as is. The last thing we need to set is moving. Sorry, not get, we want to set it. And to do that, we're going to, I'm just going to get pawn owner. And from here, I'm going to get velocity. And we're going to get the length, so vector length squared. And if that is greater than, let's say 60, keeping in mind that this is a squared value, so it's actually, if the speed is greater than that, the square root of 60, then we will say is moving is true. So this is just a simple setup. You can do your state transitions any way you like. This is just how I've done it for demonstration purposes. Okay, so we're pretty much done setting up our animation graph. We do need to go back now to our character and fix a few things up. So on our trajectory generator, we need to set our motion match config that we created, so our tutorial config file here, and we might want to change a few other things. I've already changed the max speed, so that is all well and good, but we do need to set the input to our trajectory generator. And I'm going to do that on tick. Now you could do this, of course, through events any way you like, but I'm just going to do it for demonstration purposes. Again, this is not, or I'm not doing best practice here on purpose, just for speed's sake. So we'll get our trajectory generator, and what we want to do is we want to set trajectory input. So if you want to do it through events using like both the x-axis input, you can go set trajectory x and y separately and do it that way. But I'm just going to do them both at once. And the reason is I want to transform the input to the camera. So I've got two inputs here. So move x. So I've created these inputs in the project settings. And we could plug them in here. So get move y. We could plug them in here, and that would work, but I want to make them relative to the camera. So let's do a little bit more work so that if we have a moving camera, which any game would, it can be relative to that. So we've got a utility function called from Motion Symphony called get vector relative to camera. This is part of the Motion Symphony Blueprint function library. We can plug in our move x and our move y. We just need a reference to our camera component, which we'll drag down here, plug it in there, and we will get a return value, which is a vector. I'm going to split this struct pin, and I'm going to plug in the X and Y value there. So there we go. That is the setup for the trajectory generator input. Let's go to our project and see if it's working. Chances are with all these steps, I've probably made a mistake, but we'll find out very soon. I'm going to change my default pawn now to a tutorial character. And let's just save all and hit play. And it's working. There we go. I didn't make a mistake. Surprised myself. So there we go. That's pretty decent animation right there, just with the default settings. I haven't done a lot of tagging or anything. It's quite, yeah, I'm really happy with that. I think that is just about all we really need to do for a quick start tutorial. Actually, there is one more thing that I will do. I will show you first the debugging. So if we type in tilde to bring up the console, we type in a.animnode.mosymph, and here are all the mosymph debugging options. I'm going to go to trajectory and set it to 2. And now we can actually see the trajectories. So the green trajectory is the desired trajectory. That's the input into the motion matching node. And it's the one that I'm controlling with my keys, my WASD. So yeah, the trajectory generator takes that input vector and generates this trajectory. You can see it's constantly recording the past trajectory as well. Now the red trajectory is the trajectory of the pose that was chosen by the motion matching node at whatever last time the motion matching search took place. And you can see it's constantly trying to get one with a trajectory that's close to the green trajectory, also keeping in mind pose as well, because it's also matching the pose as well as the trajectory. Now there is one problem that I want to address before finishing this quick start tutorial, and you can see it on the screen now. The red trajectory and the green trajectory aren't perfectly aligned, and that is because it is impossible to have enough coverage to have every single angle of movement. You might want to turn 32.5 degrees with your input on a joystick, for example, but you don't have an animation that's going to exactly turn it 32.5 degrees, so we need to do some procedural rotation. I call this error angular error warping, and let's just quickly fix it up. So let's go to our tutorial character, and I'm going to add a component called trajectory error warping. And this is a simple component that's going to procedurally rotate our character in the yaw axis. And let's just set some settings. So we've got a warp mode here. There are two different warp modes really. We can also disable it, of course. The standard warp mode and the strafe warp mode. If you're strafing, set it to strafe. If you're not, keep it at standard. We have a warp rate. This is in degrees per second. So how fast are we going to warp? Rotate the character. We don't want it to be too quick, otherwise it'll be not looking good. Or if maybe we want more responsiveness, maybe we want this to actually help with responsiveness, and we can ramp that up as well. We have the minimum trajectory length. This is basically to stop it trying to warp while it's idle or just going really, really slow or something like that. And we also have an angle range in which warping is to take place. In this case, I've got 0.25 degrees to 30 degrees. So if it's close enough, so if it's under 0.25 degrees, the error, it's not going to bother warping. If it's greater than 30 degrees, it's also not going to bother warping. And the reason for that is that if it's greater than this amount, we should be using an animation to change the direction of the character, not procedurally rotate it. If we don't do this, the character will do something like a 180 plant, and this component will try to rotate the character while it's doing that, and there'll be foot sliding and it'll look awful. So it's important to keep this value between 20, 30, 40 degrees. It really depends on how much coverage you have, but 20, 30 degrees is fine. Maybe 40 degrees if you're using cut clips, but don't go too crazy with it. We do need to manually update this though. It doesn't tick on its own. I didn't want it to do that. I wanted that to be an optional thing, so you can tick it when you want and tick it when you don't want it. So we'll just use this function. So we get our trajectory error warping, and we use apply trajectory error warping, and we can plug in the delta time, and that is pretty much all we need to do with that. I shall hit play. And we should get the character lining up a little bit better than before. Now, of course, the trajectory is constantly changing, and because I haven't set up a constant looping animation, you'll notice that even when I'm running straight, it is changing a fair bit, and therefore the warping doesn't apply. You know, it's constantly fighting against it. However, if you had a looping animation that does run perfectly straight, it will warp much more nicely for you. So there we have it. That is the quick start guide for motion matching. I'm actually surprised. I thought I would have to do a lot more editing to get it working this well, but we can already do things like plants and stuff. Did I add counterplants? I didn't add counterplants. Let's quickly add counterplants just for a bit of fun. Go to our animations here. We'll pick some more animations and we'll type in plant, run counterplant. Let's add these two here. And I think these will be fine as is. If we play, you'll see that he turns the wrong way every time. So he'll turn left to go right, right to go left. I might just do not use these first two because I've already got 180s and these are quite slow. They're quite slow turns, these first two turns. See, it's like stop, stop, stop. The idea was to sort of turn on the wrong foot, do a 180, but I'm not convinced that the results are good enough to be worth using. So I'll cut out that whole bit there. Let's have a quick look at this one. Do not use. I'll add in another do not use tag just for the beginning here. There we go, it's a pre-process. And we'll save that. And we should be able to do counterplants. There we go, there are our counterplants. So we want to go left, but oh no, I changed my mind, I want to go right. And it's faster to turn in the direction that you're going, continue turning in the direction you're going, than to stop and then change direction again. So that actually helps a lot with responsiveness. Now, a word on responsiveness before I end the video. The responsiveness of motion matching is going to be the responsiveness of your animations. If you have really slow, sluggish animations, then your motion matching is going to be slow and sluggish. There's only so much the system can do with trajectory error warping with the quality responsiveness slider. So if you take mocap data and you want to make a really fast-paced, responsive game, you're going to have to modify your mocap data so that your turns are faster and all that. Just something to be aware of. Anyway, thank you for watching. This has been quite a long video, but we've created a full motion matching character here, which is working pretty well. We'd go in and add walking and all that other stuff later, but have a look at the example project. It's a bit more further developed than this, but it's basically along the same lines. So again, thank you for watching. I will see you in the next tutorial and other quick start tutorials. So again, thank you for watching, and I'll see you in the next tutorial.